Hi everyone. We are solving inequalities, and we're going to go through some properties and some examples. The first property I have is the addition property of inequality, and for any real numbers, let's fill in the blanks here, A, B, and C, if A is less than B, this is the addition property, then A plus C is less than B plus C. It works for greater than also. If A is greater than B, then A plus C is greater than B plus C. We added the same amount to each side of this inequality. We added C here and we added C here. It's still less than. So that property is what we're going to be using when we solve inequalities with variables in it. And then the subtraction property, if A is less than B, then A minus C is less than B minus C. And if A is greater than B, then A minus C is greater than B minus C. The direction of the inequality is not changing. All right, let's use that property and solve an inequality here. And then we're going to graph the solution set on a number line. So that's two parts of things I want to see here. So when I solve 5w plus 3 is greater than 4w plus 9, I'm going to subtract. I'm going to use the subtraction property of equality, and I'm going to do it like we do equations. I'm going to subtract 4w from this side and subtract 4w from this side. I like to get the variable in one place first. And 5w minus 4w is w. And w plus 3 is greater than, and then 4w minus 4w is canceling out. That's why we did that. It's greater than 9. And then I'm going to subtract 3 from both sides, and I'll have w is greater than 6. So there is my solution as an inequality on a number line. Let me put some numbers here. Let's go -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, if it's just greater than, an open circle goes on 6. And numbers bigger than 6 are solutions. So let's make a heavy arrow to the right. This is what goes with w is greater than 6. All right. So we have our solution as an inequality. We have our solution graphed on a number line. Okay, we did addition and subtraction. Let's look at the multiplication property of inequality. There are two cases. Case 1, if C is positive. If A is less than C, if A is less than B, then A times C is less than B times C. I kept that sign the same. And for greater than, if A is greater than B, then A times C is greater than B times C. Multiplying by the same positive number does not change the direction of the inequality. But in the case of a negative, let me just show you what happens. Let's say I have something like -2 is less than 3. -2 is less than 3. If I multiply -2 by -4, and I multiply 3 by -4, what I have after that is -2 times -4 is 8, and 3 times -4 is -12. Now 8 is not, I don't just bring down that less than. 8's not less than 12. 8 is greater than, 8 is not less than -12. 8 is greater than -12. A positive is greater than a negative. That's what happens when you multiply by a negative. If C is negative, 8 times C is greater than B times C. That's if A is less than B. If we multiply by a negative number on each side, we switch we flip the inequality. And if A is greater than B and C is negative, A times C is less than B times C. Now the division property of inequality works the same way. If A is C is positive, that we're going to use right here, A divided by C will be less than B divided by C, and A divided by C. If A is greater than B, A divided by C is greater than B divided by C. But we switch the inequalities when we divide by C and C is negative. A divided by C, if A is less than B, A divided by C is greater than B divided by C. And if A is greater than B, then A divided by C is less than B divided by C. Okay. Example 2. Let's solve this. Oops, not an equation. Let's change the equals to less than or equal to. Mishap on my part. I wonder how many. Okay. So, it's example 2. I'm going to use the addition property of inequality first and add 10.7 to both sides of this equation. And of inequality, careful how you say that, negative 9.2y is less than or equal to, just bring it down, 22 and 1 is 23. Okay. So, I'm getting my calculator real quick. Wasn't prepared. All right. Now this next step, I am dividing by negative 9.2. This is the only really special thing that you wouldn't have to deal with equations. But when you divide by a negative, we've got to switch. This is negative 9.2 there. We got to switch that inequality. And let's take 23 divided by negative 9.2, negative 2.5. Y is greater than negative 2.5. Now, I'm also going to put this on the number line. I didn't put that in the instructions, but I'm going to do that. And I got negative 2, negative 1, 0, 1, 2, 3, 4. Okay. Negative 2.5. Oops. I didn't draw this number line very well. Let me extend over here a little bit. Ignore this little arrow here. I got negative 3, negative 4. So I'm going to kind of go halfway in between. This time I'm going to put at negative 2.5, halfway between negative 3 and negative 2, a solid circle because it's greater than or equal to. This line will make it a solid circle. And then I'm going to draw heavy arrow to the right because we're greater than or equal to. Okay. Make that point a little more prominent. That's halfway between the negative 3 and the negative 2. So y is greater than or equal to negative 2.5. Okay, now we just have some multi-step inequalities where we're going to use these properties. And first thing I'm going to do in this problem is multiply both sides by 5. Now I'm multiplying, so I got negative 15x is less than or equal to And the 5's cancel out here. Negative 4x plus 22. I did multiply both sides by 5, but I multiplied by a positive, so I did not change that direction. The next thing I'm going to do, I'm going to add 4x to both sides. Now negative 15x plus 4x is negative 11x. That's less than or equal to 22. And then I'm going to divide by negative 11. When I divide by a negative, you got to remember to switch or flip the sign the other direction. X is greater than or equal to negative 2. Okay, so I'll make a short little number line. Greater than or equal to. Here is negative 2. I'm coloring it in because of the or equal to part. And I'm going to make a heavy arrow to the right for numbers greater than negative 2. Can equal negative 2, which is why the solid circle's there, and it can be greater than negative 2. All right, one more example, which I forgot to write down. Let's take, and we will solve negative 5 times 3d minus 7 is greater than 3 times 2d plus 14. That's a greater than, and that's a 3. Let's distribute. I got negative 15d, and then negative 5 times negative 7 is positive 35. I got 3 times 2d is 6d. 3 times 14 is 42. Now, I have to remember, if I have a negative coefficient, I got to remember to switch this. It doesn't matter which one you deal with, but if I want to ensure that I have a positive coefficient on d, I'll take the smaller value of the negative 15 and 6 and do the opposite of it. And so I'm adding 15d to both sides. That cancels. So now I have 35 is greater than 21d plus 42. And then I'm going to subtract 42 from both sides. That's the subtraction property of inequality at use here. And 35 minus 42 is negative 7. So I got negative 7 is greater than 21d. I'm going to, it's with the d, I would incline to think I would divide by 21, or by 7, but not. So I'm going to divide by 21 instead. That's the coefficient of d there. I do not switch this inequality because I've got a positive coefficient. And I'm going to simplify negative 7/21 to negative 1/3. And I'll circle that answer. Now, I like to write it with the d first. The inequality is pointing at it, so I'm going to keep it pointing at that. And then so d is less than negative 1/3. On the number line, let me put negative 2, negative 1, 0, and 1. And if I split this up to 1/3, 2/3, and this is 3/3, negative 1/3 would be this one. And I'm going to put an open circle here. This is at negative 1/3. This is negative 2/3. I'm going to put an open circle there at negative 1/3, and I'm not going greater. I'm not going this way. I want it when with my variable first. D is less than, so I'm going this way with my line. And there we have it. Here's the solution on a number line. All right, guys, you take care now.